Good morning, everyone. My name is Carl Schmidt. I'm one of the Van Meter's solution consultants and information architects. And today we're going to be talking about all in on AI use cases you can apply right now. Just a little bit about myself is I've been with Van Meter now for almost 30 years, working in a number of different roles, technically focused. And glad to be here. I've followed AI and advanced analytics for the last 10 years, and it's exciting to see where things are going. And today we'll cover where AI is, but more importantly, we'll talk about applications that if you wanted to tomorrow, you could actually go ahead and implement with our team.
I'm Tony Etten. I've been with Van Meter for almost 2 years. I'm a solutions architect, and we've been focusing on AI because everyone seems to be interested in AI, and that is kind of the way that technology is going in your production environments. So hopefully you will find some use cases here that you can apply in your situations that you guys have.
So normally when we talk about AI with our manufacturing customers, I'll ask them if anybody from their organization is using AI, and I'll get mixed results. I'll get that some are using Copilot and using some of the generative AI. Others actually do have some of their team members that have went through training and are um, actually starting to invest in small projects with AI. And on the farther spectrum, I do have manufacturing organizations that have actually invested and hired data scientists. One thing is for sure, and you see it from the results of this State of the Manufacturing report that actually was generated in 2024, is that manufacturers are investing in AI. They feel it's one of those game-changing technologies that can help them really move forward. One of those other areas that a number of manufacturers are looking at is as they really go ahead and try to drive greater productivity, and as they really try to advance in the marketplace, is that improving quality is also one of those big focal items. The ability to be more productive, the ability to lower their cost to produce. And AI is one of those technologies to go ahead and impact quality. And closed loop quality is one of those solution sets that many of our manufacturing customers are looking at. And so we feel there is a bright future and timeline with AI that can really help manufacturers drive business outcomes. And so they're not only the ability to optimize production, which is one of those key things that as you look at the adaptability to your supply chain and to your market, and the ability to adapt as that changes, the ability to build resiliency. So as you look to be more predictive, and as you look to foresee those disruptions, whether they be from a holistic supply chain aspect of things, whether it be on your manufacturing floor and the ability to predict where your downtime might be coming. Building resiliency is one of those big initiatives for many of our manufacturers. The ability to empower your people. We've seen in the last 3 to 4 years, one of the biggest challenges has been the workforce and the experience that is leaving the manufacturing setting. The ability to provide that guidance to your team members, whether it be on the front line, whether it be for some of your knowledge workforce, that really the ability to close the gap with providing them information and more importantly, timely information. And that's where AI can fit in. As you look at driving sustainability and the ability to really reduce your bottom line costs, these days energy is one of those focal points for many of our manufacturers. And so putting this all together as you really look to make step changes in how you manufacture and how you your end-to-end supply chain and manufacturing footprint approaches being different in the marketplace, that's where AI and some of these other technologies can help you out. So we see that it's not only just manufacturing, but as we look at key things with it, they see that production logistics as a subset of manufacturing is one of those game-changing places where manufacturing organizations can be more impactful. So we also see it through the full life cycle of manufacturing, from design to manufacturability, to really front and center operations and in driving operational excellence, to really being able to ensure that your assets are producing and producing on time with minimal downtime. And so we see as customers look to really drive bigger gains and even move towards autonomous, whether it be in certain areas or across the manufacturing footprint, that AI has a very, very bright future. So as we sit down with manufacturing organizations, we know it's a journey, and so it's important to look at where you're at today and where you really want to be tomorrow. And that has to weigh in on how you approach using AI. If you're a plant that is maybe pre-digital and your team members and your operational workflow relies on paper, it may be tough to jump to being a predictive plant, but that's where our team working with your team will really take that into account on what the steps in that journey need to be. A number of our manufacturing customers say, and on average, our larger manufacturing customers say that they're really in phase 3, which is a connected plant, where there is connectivity between their production assets. There is some level of connectivity from their business systems. They do have records, and there are some analytics that are semi-automated, but the key thing is where your organization is at. And AI can be implemented in focused solutions, even if your plant is really in a phase 1 or phase 2 type of scenario. And then ultimately, as we look at driving value, the ability to be predictive and the ability to be adaptive and the ability to adjust to have a resilient manufacturing footprint, and driving to what we call self-aware, the ability to have diagnostics and the ability to adjust, and can drive a lot of value. So just to kind of level set and give everyone some ideas on where AI is being used. It's being used up and down the manufacturing technology stack. And so at the enterprise level, if your organization has struggled with supply chain planning, demand planning, that's where AI can help out. As you look at your mix of orders, and if there's still opportunity there for order fulfillment optimization, that's a great opportunity for AI. And as you look at the workflow, I should say, from design to manufacturing and that closed loop of it, that can also be an area for AI to be used within PLM. And as we move down the structure there, as we get to really closer to the manufacturing floor, as you look at how your team is executing finite scheduling and all those different scenarios and disruptions, that's where AI can help out. A huge focus, and one that we are working with our manufacturing customers on, is predictive. How can we help your team be more predictive, especially as you look at low-hanging fruit around maintenance and the ability to understand where the next downtime could be and where your team could really prevent it from happening. As you look at your energy footprint, and if energy is a space that your organization really needs to see some cost-cutting efforts, AI around energy can help out. Material optimization is also one of those things. As you look at your waste, uh, is ability to go ahead and optimize the usage of your ingredients and materials, um, not only from a usage standpoint, but also from a quality perspective. And so as we move further down the chain, as we get to your production assets and your automation layer, there's a number of things that can be done, and we'll talk through those. Adaptive control and being able to tune exactly to how your production asset needs to be running is very, very important. And the ability to drive greater capacities, whether it be with adaptive tuning or whether it be with model-based control methodologies. But even moving further than that, as you look at where you're going to expand and the ability to actually simulate how your production processes are operating and the ability to fine tune using AI is one of those things that some of our best in class manufacturers are really investing in. And then we look at really helping your team members, and that's where agent-based AI methodologies can really help out. And then we get into your assets and where there are challenges, and those things that really cause havoc is using soft sensing to go ahead and catch anomalies before they really take you down. And then as we think of the quality piece and really impacting quality, and as we think of the autonomous piece, that's where we look at machine vision and the deep learning technologies that are there in that space. So we see that this is a kind of, I'd call it a frontier where there's more and more applications being deployed each day. And it's an exciting time and space. So now you may be excited, but you may be asking, Carl, what are the challenges? Well, first and foremost, what we've heard from manufacturers, and this is from that a similar survey, is that most manufacturers really feel they have the data, but they're not using the data effectively. And so as you look to move towards using AI and machine learning, it's really important that your team has good data, because bad data will drive a bad model and bad outcomes. And so as you look at the process and some of our manufacturing customers are really looking at where do we start. And so you have to have good data. And our team would say from Van Meters is before you even think about the data piece of things, think about the business objective. What's that business target? And so CRISP, or the Cross Industry Standard Process, is a recognized model for how you approach AI. And so I bring this up because we mentioned you have to have good data. First, again, as you approach developing AI, it's important to first have that business objective. And is there the right opportunity for your team to invest? So start there. Does it make business sense? Does it align with your initiatives? Once you've decided that yes, this is a good opportunity from a improvement standpoint or an ROI standpoint, and that starts with gathering relevant data with context. So if today your organization is really using paper, it's important to really start collecting data, and that's where our team can help you take those first steps. Once you have the data, it's really important that that data is good and it's time aligned, and so you have to prepare that data. For some organizations, that data is housed in different places. And so having the ability or taking the time to really align that data so it's valuable together and it's accurate together is very, very important. And then your subject matter experts really have to identify the relationships, looking at the statistics, and really try to drive towards developing a model. And so if you've had team members develop models, you'll hear them talk about the scoring and training and really developing that model so that your team, your subject matter experts, have a high degree of confidence that it's doing what it should do. Okay. From there, it's really evaluating whether that model does what it's supposed to do. If it's making a prediction, it's making an accurate enough prediction that your team feels comfortable that it could be operationalized. And then it's actually operationalizing that model, deploying it to provide those insights. Now that you have that model running, uh, now it's time to really manage and maintain that model as things change, as the way that the data that's used for that model, as that application changes, that model may need to change. So it is definitely a process, and if you're using your own tools, it can be a very time extensive process. And working with some of our manufacturing customers that have invested, been doing this for a little while, and one of them is actually a degree data scientist. Working with him, his biggest obstacle was the data. From his perspective, he had a lot of data, but he had that data scattered around in a number of different areas and databases. And so he had to spend a large amount of time actually data wrangling. And so just note as you think about tools out there, as you think about investing, if your team members aren't using the right tool, they can spend a lot of time on the upfront data wrangling side of things. And we've seen that 80% of that time in developing AI is spent on the front end with that data wrangling. And then another 20% of the work is really on developing the model, testing the model, and that evaluation. So you see that there's a lot of effort before you get to where you can actually go ahead and take advantage of that model. And so we wanted to give you a little bit of background into AI, the reasons to use AI just from a holistic and a high level perspective, and just what it takes to from a general sense, take on an AI project. Now, what we're going to do is we're going to really flip the focus and talk about real world applications and solutions you can use to really solve specific applications, highly focused on the manufacturing floor. So again, if you said tomorrow, I want to go ahead and invest, you could. And so the first few sets of applications we're going to focus on are going to be really what I call production or operational focused. This first use case I'm going to talk about is we're going to spend some extra time on because you'll see a number of different use cases that kind of fit the same scenario and so on and so forth. And so, like I mentioned, is it's very important to um, really think about that use case and what's the operational value. Strategically, what's the ROI look like? And it doesn't have to be a wide encompassing application. And we'd actually suggest is really focus on a very um, focused, determined use case. Because many times those very focused use cases can have quick time to value, but they can also drive a lot of value as well. So this first use case happens to be on what we call perfect fill and eliminating those giveaways. So if your organization sells some of your products based on weight, based on volume, you know that there's a minimum that you have to provide or you have scrap. But there's also that extra that you've always put in as that buffer just to make sure that you're providing the required amount. And so in this case, it happens to be water, and this is a published use case with Unilever, and their average water bottle is 600 grams, and they were typically filling to 608 grams, so 8 grams of giveaway. And so we mentioned focused for Unilever on one of their production lines with their cycle times. This 8 grams of giveaway was adding up to over $1 million per line. Okay. And so as we think about AI and as we think of getting more predictive, the ability to dial that in. So in this case, what we're focused on is those overfills and reducing that. So what would it look like, for instance, if we could cut that in half? So as you look at your use case and looking at the bottom line impact, looking at what the difference could be, is really a good first step to take as you look at analyzing if an investment makes sense. Okay. So one of the very, very, very common use cases for AI is really reducing variability. And how do we do that? We leverage the model to predict where that variation is going to take place. So in the use case for perfect fill, what we're doing is we're looking at a number of the system variables as we fill up the water bottle. And we're actually tightening the variation. And so instead of having to buffer with 8 grams of product, since we're able to tighten up that variation, we can lower that set point and reduce it to 4 grams, or even in this case to 2 grams. Okay. And so as we talk about these other use cases, being able to predict and tighten that variation is a very common thing that we do. And so here we used one of our tools, and Tony will talk about this tool, FactoryTalk Analytics, LogixAI in more detail. But our variable interest would be the dosed weight of water into the bottle. And we combine a number of key system variables together to really dial in, making sure that every time we provide only 2 extra grams of giveaway, knowing that if we're below 600 grams, that becomes scrap. Okay. And so in this case, we're dialing in system pressure, we're dialing in system temperature, system speeds, and the level of the buffer tank to go ahead and make that prediction of do we need to fill a little bit more or fill a little bit less, so that we maintain that 2 grams extra that's going into that bottle. And we're doing that at a very, very, very high speed. And so that's something as you think about your use case is what's most important as far as the latency of the model or the speed of the model goes to make sure that it drives the greatest value.
So to continue that topic with different use cases and examples, we're going to talk about drying. So in the agricultural area, they have a lot of times they have to take their materials and dry them, and then they're watching that percentage of moisture content. So when you're using LogixAI, you want to have that variable of interest. And in this case, it's that moisture content. Very much like the perfect fill, there's that one variable that you really want to control. Where in this case now, they would typically have to take some of the material, pull it aside, weigh it, dry it for up to 4 hours, and then weigh it again. So it's very time consuming. And in that time, the process could be deviating and changing. So with LogixAI implemented, it is, again, that model is there and it's learning and watching all the variables that can change that moisture content. So it's taking that real-time data and making real-time trends and real-time predictions. But also with the measurements they've taken, they can implement that and put that back into that model. So LogixAI can use that also to better the model and continue to make that model better. So again, in this case, it's that closed loop. LogixAI will be making changes on the front end to those variables that are impacting that moisture content so that the end result, as Carl was saying, it keeps that variability a lot less and a lot closer to their set point that they are trying to target. The next example, so again, we're just trying to give a few different examples so you can get an idea of how to use LogixAI in your use case. So another one is an air compressor, and this is more on that predictive maintenance area. So in this case, traditionally, like 90 psi is what's needed to run all the air equipment in a production environment. So your whole plant would be running on maybe this one main air compressor or two or whatever, but 90 psi is what it's targeting. So that, again, that variable that you want to control is that psi and that pressure in the air compressor. Well, it doesn't happen very often, but sometimes the air compressors will fail and they just kind of degrade over time so that you maybe aren't hitting that 90. Well, if you've been in an environment where the air compressor gets below 90, it shuts the entire facility down. And then everybody has to wait. So maintenance is very reactive, trying to get that air compressor back up. So in this case, if you put LogixAI in, it can watch what traditionally it would be running at. So it's going to be watching that air compressor value. And if it's degrading slowly over time, it's going to be watching that and monitoring it. And it can give you an alert letting you know that in the future, in this amount of time or whatever, this pressure value is not going to be high enough to run your facility. You can set it so that it gives you a long enough lead time so that you can, maybe you have a company-wide meeting. And in that time, you can schedule maintenance activities so that you prevent a failure from happening at all. So now instead of being a reactive maintenance organization, you can be proactive and get that air compressor fixed and back up to running at a higher pressure rating than it has been going down. So again, just doing that preventative maintenance task. You can use, again, LogixAI in that scenario as well. Then the final one I wanted to talk about is an example of rolled products. So this is now, again, rolled products are typically made very high speed, very fast, rapid application. And a lot of times it's in a harsh environment. Well, the position of that rolled product is pretty important for downstream equipment. Think of if you have to cut it or put perforations in it or print on that rolled product, you need to know exactly where it's at so you can get that in there correctly and applied appropriately. Well, there's a lot of sensors watching this to make sure that position value is transitioned to the downstream equipment. Well, if one sensor value goes bad, it can stop the whole line because something's abnormal and it's not in spec, and so it will just stop the whole line, and it could scrap that whole batch, that whole run. Where if you introduce LogixAI, it can now watch and it can understand your process and know and predict what the sensor value should be. So let's say one sensor out of 4 starts showing some weird value. It can give you, LogixAI can give you an alert, and you can choose to use the LogixAI data in place of that sensor that may be faulty. Let's say you have 4 sensors, 3 of them are reading normal and 1 is weird. You might just think that, yeah, it could be a bad sensor. It'd be nice if LogixAI could use its values, and that's what you can let it do. You can then say, yep, use the LogixAI values. Then after this batch or this run of material, we're going to take our maintenance staff and we'll go in and make sure that that sensor is functioning normally or just swap it out. But what it's going to do, it's going to allow you to finish that batch and do a controlled shutdown after that, again, that batch or that part is finished being made. And if you find out that that sensor value was correct and it was bad, well, it would have been scrapped anyway. Where if you can put the LogixAI data in, you might have just saved that whole batch, and now you can, again, replace that sensor during downtime. And so you didn't cause any scrap or any issues with that product. So really looking at LogixAI, hopefully those examples helped give it some meaning and how get you starting to think about how you could use it in your environment, in your application. And really any application that can be modeled with a mathematical formula or follow the laws of physics, that's what LogixAI can model. So think of any process that you need to control. If you have a variable that you need to control and it can be, again, modeled by a formula, LogixAI could be something you could use to model it and monitor it for you. Next slide. Is not going to eliminate your controls engineers. We still need them. They're very important. You're going to need somebody that knows the process really well to set that model up. So they're going to set that variable of interest. So in that configuring, they're going to identify the data. Again, which variable are we trying to control and which variables could be affecting the variable that we're trying to control. They're going to set all that up. The part that LogixAI does is actually set the model and watch over time how the impacted or variables impacting that variable of interest are behaving and what's happening. It's going to model all that. And when the model is ready, it'll start monitoring. It's basically going to take those two processes and automate that and make that a computer basically run system, because those two things are really hard for a human to do continuously. It's just one of those tedious tasks that humans need breaks. They can't just sit there and monitor the data, where a computer can sit there and watch it all day long. And so then that's the part it's going to give you. And then it's going to give you some of the results, or in that closed loop, it'll change the variables to make sure that your variable of interest stays within the tolerance and the limits you've set for it. Next slide. And so really, overall, when you're looking at LogixAI, it's really enabling those outcomes. So you're going to have anomaly detection in some sort. So it's condition monitoring, sensor validation. And really, when you look at it, there's kind of three anomalies that are basically going to be detected. One, an anomaly could happen and your line could self-adjust. LogixAI will then record that and it will realize and learn from that, hey, when this happens, I might not need to do anything right away. Just let it sit and it might fix itself. The second example would be if it happens and it doesn't fix itself in that certain amount of time, LogixAI in that closed loop system can adjust the variables that are impacting that variable of interest and make it so that it can keep that variable of interest, again, within that tolerance. And then the other one is, again, replacing sensors. So again, soft sensors, it's going to predict what the sensor value should be. And if there's a faulty sensor and you are pretty sure it is, go ahead and let LogixAI do that from there. Next slide. And then the other thing is that virtual sensing, like we had said, it can replace a sensor, but the big benefit that LogixAI offers on the AI side is all of the thinking that it's doing basically for you. It's pulling that data, it's looking at all this data coming in probably pretty rapidly because it's real time, and doing that predictive analysis and determining what the outcome will be. Something that, again, as humans, you can guess at, but you don't really have the ability to take in all of that data and really determine what it's going to be. So again, that's where LogixAI would really fit in well with this. And then on this last slide here, we're really looking at, this is how you're going to set it up. It's kind of a hard concept to get, but the model itself, once you know what you want to control, that's going to be your variable of interest. And then as someone who knows that process well, they would be setting this up. You can put in all the other variables that you think are contributing to making the variable of interest good or bad. And again, you can see on this graph here that LogixAI will take all the inputs you gave it and it will look at them, but it will actually determine which ones are actually contributing and which ones are not. So if you put in something that really isn't contributing to your variable of interest, it doesn't matter. It'll just ignore it and it'll know, like in this case, these top three are the ones that are actually affecting my variable of interest. So that's what I'm going to control. And so again, it's going to help just keep that process under control. And again, any process that can be formula based or follows the laws of physics can be modeled in LogixAI. So hopefully you can find some use case in your facility where this would be beneficial.
Thanks, Tony. So now we're going to jump from more of an operational production focus to AI and predictive maintenance. And so one of those areas is kind of like Tony mentioned and elaborated on from using LogixAI is actually anomaly detection. And we would say we want to get to where it's really anomaly identification. using one of our other tools called FactoryTalk Analytics Guardian AI. And FactoryTalk Analytics Guardian AI is really designed to leverage your existing devices as sensors in the plant. And you'll see that over the lifetime of its offering that additional devices and sensors will be added to the mix to be used and leveraged. FactoryTalk Analytics Guardian AI does not use data science. So it's a quick time to value for your team, for your maintenance and engineering team to go ahead and utilize. And it does run down at the production floor. So you'll may hear that many times with AI-based solutions that they have to run in cloud format and use cloud computing power. This is designed to run basically on your edge-based computer or on a virtual server running in your manufacturing plant. It can be right at the production floor or somewhere on your OT network. And so with our first release, we're literally using our PowerFlex 755 drives as a sensor. It has advanced advanced safety sensing, advanced sensing capabilities built in. And so with our years and actually decades of condition-based monitoring experience, we've actually built that expert-driven analysis into FactoryTalk Analytics Guardian AI. So here you see the common first principle faults that we're automatically diagnosing for. So from a pump standpoint, cavitation, shaft misalignment, viscosity change, blade faults as an example, impeller unbalance. Similarly with fans, blade imbalance, blade misalignment, and loose blades. And then we go to just that motor that's connected, and being able to let your team know if there's unbalance or shaft misalignment, whether you have a loose footing as an example, or a rotor rub, to understand if you have early or late bearing fault issues. So we give that to your team so that they know that there is an issue, and we'll let your team know whether it's an early warning or whether it's a late warning, so that your team can go ahead and adjust and again plan for when that scheduled outage should be to take care of that mechanical issue. So we not only do that embedded expertise, but we also allow your team, your subject matter experts, to also classify. Your team doesn't have the time to just sit there and look for issues. And so what Guardian AI does is it's always listening, it's always monitoring on that motor or that pump. But we can't have embedded expertise for every different process application. As an example, I have a process customer that with their application, their pumps would often plug up with different materials running through the process. And so that's an example of a user classification where Guardian AI would actually surface up that use case. The pump is starting to plug. It would label that for your team, and that's where your subject matter expert would come in and say, yep, that's the pump plugging. And so after that, it's going to either go ahead and automatically identify that the pump is starting to plug, or in some cases, be able to go ahead and predict it. Okay. And so Guardian AI has the ability to continuously learn. So it's always looking for what's not normal and then surfacing that up for your team to go ahead and label, and then be able to leverage. Excuse me. And so out of the box with Guardian AI today, we're able to go ahead and do analysis for pumps, fans, and motors out of the box. In the future, we'll expand that to other operational assets. I mentioned that Initially, as we've released Guardian AI, it works with our PowerFlex 755 drives, our PowerFlex 6000 medium voltage drives, but it also does work with or will work with our newly released 1445 wireless condition monitoring. So here you have the ability to add wireless monitoring for balance of the plant type applications. And so that'll be also added to Guardian AI here in the near future.
Now, we've kind of given you a lot of examples on what you can do in production. And so now we're going to kind of jump back into maintenance management solutions. So a lot of organizations are really pushing to get to that prescriptive maintenance as their strategy going forward. So really I want to start with this, pyramid, just really highlighting again. I think we kind of said throughout the presentation, at the beginning when Carl was talking about just AI in general, you have to have your base model information correct, get the data correct, know what you want to do. So with maintenance, it's no different. Throughout these next few slides here, I am going to be focusing on Fix. And with that, Fix has its computerized maintenance management system and asset risk predictor. They're two different systems, but they're under the Fix umbrella. And throughout this, I'll use them as reference, but there are other CMMSs out there. But in this case, the first thing you want to do if for your maintenance department in general is to digitize. Make sure all of your maintenance activities are digital. Make sure your work orders are in there, what materials you've used, who your technicians are, how much time things have been taking, what assets you're working on. The more data you can have digitized, the better your CMMS and any AI on your maintenance will function. So again, you're kind of building your model there. And make sure that your CMMS, so Fix in this case, really has built-in analytics. So once a system has been being used for a certain amount of time and that data is there, it should be able to give you some insights as to what you've been doing to help you kind of future-proof. And so you have less emergency and reactive maintenance in the future. So again, in this case, once Fix has been being used for a certain amount of time, it might give you an insights on your assets. And you might have 3 identical assets, and it will come back and say, hey, these 3 are identical. You're spending the majority of your time on this specific one. And here's why. And it can give you all of that information. The other thing is if you use like an asset risk predictor type thing, it's going to give you, again, that risk and allow you to be proactive instead of reactive. And this is all really about driving your maintenance activities to be proactive. You're in general going to spend less time if you can be proactive because you're going to reduce downtime, reduce failures, and fix things before they break and cause more damage. But getting back to your CMMS, make sure that it can also hook up to your IT, OT networks, your ERP, so your enterprise resource planning software. Make sure it can connect to all those. Make sure that it's able to be mobile. You want it on a mobile device because a lot of times your maintenance techs, they're out on your floor looking at specific assets. So make sure that it's mobile and it's easy to use and user-friendly for them. Next slide. So with looking at kind of our systems that we have, if you're going to use Asset Risk Predictor, it's an AI tool really designed for those more critical assets to detect anomalies before they become catastrophic failures. The example I had given earlier about the air compressor, that could be a critical piece of equipment for you. While LogixAI can help tone it or, really make sure that it's holding its pressure, this can let you know about the asset itself. It's going to be looking and pulling in that real-time data on the assets themselves, again, critical assets, and it's going to give you a report daily of what assets are in a low, medium, high risk categories, however you set it. And then if you're using a CMMS with it, it can create those automated work orders. So the asset risk predictor might catch something at a high risk, and you might have set it up so that if you get to a high risk, immediately set a work order. It can pass through the request to create a work order in your CMMS. And from that, because it has those insights and it has that model built into it, it can not only tell you that this asset is a high risk, but this is what caused it. And this is the prescription on how we would recommend that you fix it and go about fixing it. And then you get into Copilot. So on this next slide, I really kind of dig more into what Copilot is. So think of Microsoft Copilot or ChatGPT. This is going to take the information from Asset Risk Predictor and your CMMS and bring them together. So specifically on this one, it's with Fix. So under the umbrella of Fix, it becomes this AI chatbot for you. So if you get your Asset Risk Predictor report and you see a high risk, and it's the first time you've seen a high risk, you can put over in the chatbot, what does this high risk mean on this asset? And it will give you as much data that it has about it. Because with the two of them working together, the Fix CMMS and Fix Asset Risk Predictor, you have this wealth of knowledge in the background and the future. So it'll have all of your digital work orders, everything you've done to certain assets. Asset Risk Predictor is watching it on real-time data, pulling in from sensors that are out there so that it knows where it's at and where it's headed. And then it also is going to pull in your your preventative maintenance tasks that you have, so your scheduled maintenance activities, and it will see, oh, hey, you are supposed to be doing this scheduled maintenance activity next week. It looks like you're in a medium risk category from Asset Risk Predictor. Let's pull it into this week. It's things like that. This is what this Copilot is here for. You can ask it questions. What are my highest risk assets? So all of that is what can become available for you if you're using a good CMMS and an Asset Risk Predictor, and it'll get you moving more toward that prescriptive maintenance model that everyone wants to get to.
So now we've talked a little bit from the maintenance aspect of things. We're going to go ahead and talk about really the art of the possible. And this is what we would say is more of a challenging application. It is an application we actually delivered for one of our manufacturing customers here a couple years ago. They actually deployed it here in 2024 fully, and it's dynamic line balancing. And so as you think of the technologies that are out there, this happens to be a visual of our simulation software running. And so let's think of just a bottling line as an example, or a canning line as an example, and you see the different production assets that are running there. And there can be a huge impact if you can optimize how these different production cells are running together with the conveyance and the material handling that's running in between them. And so what if you could dynamically adjust your bottlenecks so that you could get more product out of the system? And then that's what, when we talk about dynamic line balancing, what we're actually using. And so we're actually grabbing real-time information from each of these assets at a very high rate to be able to go ahead and make adjustments. And so there's a number of tags of information that are there that are coming in. So as we look at cycle times, as we look at the size of the data, so if you're running different production SKUs, if the size of that product is changing, we're taking that into account as we make adjustments. And so as we think about digital twin, literally here we have a what I would call a digital operational twin of each of our production assets. So here, as you see a small screen, you'll see at the bottom left is your cartoner at the end of the line. And then as we move all the way upstream to the right, you'll see our filter. And so we have an operational twin of the cycle time of that cartoner, as well as that filler, and then all of the conveyor zones between those two assets. And so we're predicting if that filler is going to start slowing down. We're also predicting if that cartoner is going to fill down. We're also monitoring and predicting when each of those conveyor zones are going to go ahead and fill up with material. And so holistically, we're actually predicting if the buffer time of that conveyor is going to fill up and when it would. We're also predicting when the cartoner would have to stop if it's going to be out of material, as an example. And together, as you look at maybe a larger connected production line, we're doing that with all of those operational assets to go ahead and predict and to adjust based on the operational cycle time and based on the buffering of the material handling between those assets. So as you look at that, our manufacturing customer had a great objective. This manufacturing plant wasn't their best. It was actually running about 50% OEE, and their goal was to get that manufacturing plant up to their company standard of 80% overall equipment effectiveness. And as we move through the project, the project team from our manufacturing customer realized that one of their biggest deliverables, not only in gaining that production boost, was going to be the amount of knowledge that they were going to be gaining. So here on the left, you see that we were able to really give them a great amount of information, very, very time sensitive and detailed information with a hierarchy that's very aligned. So their team had a very high fidelity, high rich picture of exactly what happened. So they would know when that cartoner was starting to become starved. They could really work through the cause and effects of what happened. And they could really, with a high degree of confidence, put together improvement projects that would allow them to gain even better production capacity results, better productivity. So there's the ability with the right data and with the right technology now to use AI to really help you transform how you do business. And so it's looking at the use case and then leveraging the right technology. These days, with how fast we can go ahead and grab data and really put that data together, there's a lot of opportunity out there. So as you look at where your team is at, where your organization is at, and where you look at, hey, where do I apply AI? Hopefully, there were a number of use cases where you say, hey, that's a use case that we could look at. So where do you start? What we would recommend is the approach that we use. And that's first to look at what the operational opportunity is. What would the impact be by applying that solution? Is there a great opportunity? And work with our team to understand that time to value relationship. And we're here to kind of work with you on that. So we would say first, again, look at what the opportunity is, and our team can work with you to identify the right approach and the right solution that meets your timing needs. And again, it's about impact and implementation and proving that value. And then we look at it too is many of these applications is once you get them implemented once, there's the ability to scale it across your site or across all of your sites. So as you evaluate those opportunities, we would recommend as well, look at how that opportunity aligns to your initiatives, not only today, but as you look at your 3-year or 5-year plan, look at that value impact. Also identify what the complexity is of that deployment, especially as we think about AI and where you're at and what it would take to make sure you have the right data, make sure that data is ready to be harnessed. And as we look at the right tool that can help you go fast. And so our team is here to help as you look at those opportunities and as you look at your 2-year, 3-year, 5-year plan and where AI fits in your priority list and also where other technologies apply as well. So we're here to help you as you walk through that journey.